Black holes, the ultimate cosmic villains. Just their name conjures up images of giant monsters roaming the universe, devouring everything in their path. Stars, planets, maybe even whole galaxies. If you get too close, there is no escape. It is all over. But is this fear justified? Are black holes really the galactic vacuum cleaners they are made out to be? Spoiler alert, the answer is no. Today, in Myths of Physics, we are diving into the dark side of black holes to separate the facts from the fiction. Let's start with the basics. What actually is a black hole? It is not some giant celestial monster with an appetite. A black hole is a region of spacetime where gravity is so strong that nothing, not even light, can escape from it. This happens when a huge amount of mass gets squeezed into a tiny space, creating an incredibly dense object. At the center of this region is the singularity, where gravity becomes theoretically infinite. Surrounding the singularity is the event horizon, the point of no return. Once something crosses that threshold, it is gone forever. So, here is the big question: does a black hole suck in everything around it? The answer might surprise you. The reality is that a black hole's gravitational pull is not magical or unlimited. It behaves like any other massive object in the universe. If our Sun, for example, were magically replaced by a black hole of the same mass, Earth and the other planets would continue orbiting it in the same way. Sure, we would lose sunlight, which would be bad for obvious reasons, but the gravitational pull on Earth would not suddenly increase or drag us in. A black hole only affects things that get too close, and by too close, we mean close enough to cross the event horizon. So, how does something actually fall into a black hole? The key is distance. Gravity gets stronger the closer you are to a massive object. For a black hole, this increase is dramatic because all its mass is concentrated in such a small region. But for anything far away, its pull is no different from that of a star, planet, or anything else of similar mass. To be pulled in, an object has to lose enough energy, such as through friction or collisions, to spiral closer and closer until it crosses the event horizon. This brings us to another common myth: the idea that black holes are growing larger and larger by consuming everything in their surroundings. While it is true that black holes can grow, they are not as greedy as you might think. Most black holes are surrounded by vast empty spaces. Even in the densest regions of galaxies, the distance between stars and other objects is enormous. For a black hole to capture something, it has to get very close, and most objects simply do not. Now, what about those dramatic depictions of black holes devouring entire galaxies? In reality, a black hole does not have the gravitational reach to destabilize an entire galaxy. Supermassive black holes, which sit at the centers of galaxies, do influence their surroundings, but their reach is limited to the nearby region. Stars in a galaxy's outer reaches are not in danger of being pulled into the black hole. In fact, galaxies have existed for billions of years with their black holes in place, and they are still here. Finally, let's talk about what happens to objects that do fall into a black hole. This is where things get wild. Anything crossing the event horizon is essentially lost to the outside universe. But what happens to it inside? The short answer is: we do not really know. General Relativity predicts that everything is crushed into the singularity, but quantum mechanics suggests there might be more to the story. This is one of the biggest mysteries in physics today. So, to wrap things up, black holes are not the cosmic vacuum cleaners they are often made out to be. They do not roam the universe devouring everything in sight, and their gravitational pull is no different from that of any other object of the same mass. While they are fascinating and powerful, they are not the unstoppable monsters of science fiction. Black holes are incredible windows into the laws of physics, but for most of the universe, they are distant and non-threatening. Thanks for watching this episode of Myths of Physics. If you have other cosmic misconceptions you would like us to tackle, drop them in the comments below. And if you enjoyed this video, give it a thumbs up and subscribe for more deep dives into the science that shapes our universe. Until next time, keep asking big questions, and remember, the universe is often stranger than fiction, but it is not out to get you.